Good morning to everyone. My name is Venkateshwar Rao, lecturer in computer science. Today we discuss about data types, declaration of a variable, assigning values to variables, and various operators in C. So what is data type? So the kind of data that a variable may hold in a programming language is called data type. See, the kind of data that a variable holds or the data that a variable holds is called data type. The data types can be classified into following types. First one is built-in or primary data types. Second one is user-defined data types. Third one is derived data types. And fourth is empty data types. Okay, so the classification is shown in the following figure. So here this is the data types classified into four various types: primary data type, user-defined data type, derived data type, empty data type. Again, the primary data types are four types: integer, character, float, double. And user-defined data types are two types: type declaration and enumerated data types. And the derived data types are classified into various types, that is arrays, pointers, functions, structures. And empty data type is classified as void. Void is also a data type. So all these are the classification of data types. And here the data type character, okay, is represented as char. This is the keyword for character, char. And the character requires 1 bytes memory to store the character variable. And integer, for integer, we use a keyword called int, and it requires 2 bytes of memory to store the integer variable. And the signed long integer, okay, for this we use the keyword long, and it requires 4 bytes of memory to store the long variable. And signed precision floating point number, okay, and the keyword for this is float, and this is also requires 4 bytes of memory to store the float value. And the double precision floating point number, okay, the keyword for this is double, and it requires 8 bytes of memory to store the double variable. So here the char refers to character. CHR refers to character, and it holds one letter or one symbol. And int refers to an integer. Okay, it can hold signed or unsigned whole number. And float refers to floating point or real number, and it can hold a floating point number. That is like this is the example for floating point number. That is it holds or it contains 6 decimal digits in decimal or exponential form. So it is having 6 decimal digits, and a floating point number using 6 decimal digits is called signed precision number. So this is an example for signed precision number. And the double is also referred as floating point or real number. The double is also referred as floating point or real number, and it holds a real number in double precision. The float holds the real number in double precision, and the meaning of double precision is nothing but it uses 12 decimal digits. So here it is having total 12 decimal digits after the decimal point. So this types of number is called as double, or it is also called as float point value. And let us see the examples for various data types with syntax and examples. For integer data type, see this is the syntax. Okay, and the syntax is int space variable name ends with semicolon. And the example for this is int space a comma b comma c comma g is equal to 10. See a b c g, these are nothing but variable names, and we are assigning a 10 to a variable g. So this is called assigning a variable. And for long int type, the syntax is long int space variable name. Okay, so this is the syntax, and the example is long int. So these are the variable names a comma b comma c. A b c are the variable names. And here this is the example for character. The syntax is char space variable name ends with semicolon. An example here, this is the example char m comma n comma s of 50. So here this is also ends with semicolon. So here m and n are character variables. These are the character variables, and s of 50 is a string of character data type. So it is nothing but a set of characters. S holds a set of characters. It holds total 50 characters starting from index 0 to index 49. It holds total 50 characters, and it is a string. S is a string variable. Next, here it is a point data type. Okay, float data type. So it is the syntax. The syntax is float space variable name, and this is the example float b comma g comma c. See b, g, c are the variable names, and the variable names can be of anything. This can be any variable value. And next one is a double data type, and the syntax for the double data type is double space variable name. An example is double space p comma s. P comma s are the variable names of type double data type, and BGC are the variable names of type float data type. So next, see, next we discuss about declaration of variables and assigning values to variables. First we discuss about declaring a variable. How we can declare a variable in C. So in C programming, a variable can be used to store a value of any data type. A variable is basically it is used to store the value, and every variable used in the program must be declared. So before you go to use the variable, it should be declared first, and then you have to use it in the program. At the time of declaring a variable, you have to specify the data type. So the variable, when you are going to declare the variable, you have to mention the data type of that variable. So here it is the syntax to declare a variable. So this is the syntax: data type space v1 comma v2 comma v3 and so on. Vn ends with semicolon. So this is the semicolon. So here data type is any data type. It can be integer, it can be float, it can be character, it can be long, it can be double, anything. This can be any data type, and these are the variable names. v1, v2, v3, vn, these are nothing but variable names. Okay, and if you observe this example, see float space p comma t comma r. So here p, t, r are the variable names, and float is the data type. The meaning of this declaration is pt are the variables of type float data type. pt are the variables of type float data type. So here the variables can also be defined in multiple lines. So here we declare the variables in single line. We can also declare the variables in multiple lines also. So here observe this syntax here. So data type space v1 ends with semicolon, and data type space v2 ends with semicolon, and so on. You can declare data type space vn with semicolon ends with semicolon. See, this type of declaration is called as multiple line declaration. Multiple line declaration. So this is a single line declaration. See, example of the for multiple line declaration is, so here it is int code. So here this code is of type integer data type. and char sex. Here the sex is of type character data type, and float price. Here the price is of type float data type, and char name. So here it is name. It is defined as array of characters or set of characters, and name is the variable name of that array, and this array holds total 10 characters starting from index 0 to index 9. Total it holds 10 characters. So this type of declarations are called as multiple line declarations. Variables are declared in multiple lines, and each and every variable is different data. Here it is integer, here it is character, here it is float, and here it is character. All are having various data types. So next we discuss about initializing a variable or assigning a values to variable. Okay, we can also assign the values to the variables. That is called as initializing variable, or we can also call it as assigning values to variable. So variable initialization means assigning a value to the variable. The meaning of this variable initialization is nothing but assigning the values. And initialization of variable can be done using the assignment operator. So here this is operator. This operator is called assignment operator. The equal symbol. This is the assignment operator. And variable should be declared in the C program before it is to be used. See, before you use the variable, you should declare the variable. And the syntax for declaring a declaring initialized variable is shown here. So here it is, variable is equal constant. A value constant is assigned to the variable, and this can also written as data type space variable is equal constant. A constant value is assigned to the variable of this data type. Okay, so this is the initializing a value to the variable. We are initializing some constant value to this variable, and this variable can be of any data type. This variable can be of any data type. So here these are the examples here. So if you observe, so here it is, int I is equal 29, else with semicolon. Here the value 29 is assigned to the variable I of type integer data type. And here it is, float f is equal 29.77 ends with semicolon. Here the value 29.77, this is the float value. This value is assigned to the variable f, and f is a float data type. F is a float data type. And next example here it is, char c is equal, so this is the single quote, within the single quote we are declaring 1, or we are declaring L. Nothing but L is a character, and the value is assigned to the variable c, and the c is a character data type. This is a character data type. And here this is the example, int L is equal, A is equal, K is equal 29. So we are assigning 29 to K, at the same time we are assigning 29 to A, at the same time we are assigning 29, the value 29 to L. The 29 value, the value of 29 or the constant value 29 is assigned to K and A and L. So this type of declaration is also possible in C programming. And next we discuss about operators. Okay, operators and expressions. First we discuss about operator. See, an operator is a symbol. Operator is a symbol that specifies the type of operation. Each and every operator will specify some operation, or it performs some specific operation. And these are used to perform basic arithmetic and logical operations. The operators will perform arithmetic operations, logical operations, and comparison and also manipulation operations. So here the value that can be operated by these operators are called operands. The value that can be operated by these operators are called as operands. The operators are classified into unary, binary, and ternary. The operators are three types: unary operator, binary operator, ternary operator. See, the unary operator performs operations on one operand. The binary operator performs operations on two operands. Whereas the ternary operator, this performs operations on three operands. See, this is the example. Okay, by this example you can get an idea about operator and operand. So here it is A plus B. So plus is the operator, the plus symbol is the operator, and A and B are the operands. A and B are the operands. If you write A minus B, the minus is the operator and A and B are the operands. If you write X into Y, X into Y, okay, the asterisk symbol is the operator and X and Y are the operands. Okay, so in this way you can declare the operators and operands. A plus B. Okay, A plus is the operator and A and B are the operands. And next we discuss about expression. Okay, see, expression is nothing but it is a combination of constants, variables and operators, okay, arranged as per the syntax of the language. Expression is nothing but it is the combination of constants, variables and operators. So here in this example we are going to discuss about various algebraic expressions, okay, and their equivalent C expressions. Okay, so this is the mathematical, or we call it as the algebraic expressions. So this algebraic expression A plus B into C can be written as A plus B asterisk C. A plus B asterisk C. So here plus is the operator and asterisk is the operator and A, B, C are the operands. A, B, C are the operands and plus asterisk are the operators. This is the addition operator, this is the multiplication operator. Okay, this is equivalent for the this algebraic expression in C. And next example, if you see here ax square plus bx plus c, this the equivalent for this algebraic expression in C is, okay, a asterisk x asterisk x plus b asterisk x plus c. So here if you observe a x b c, okay, these are the operands, whereas this asterisk plus nothing but these are the operators. Here it is having two operators. Okay, asterisk and plus, these are the operators. Okay, a x b c, these are the operands. Okay, this is equivalent C expression for this algebraic expression. Okay, so next example, if you see here 4ac by 2a. So this is the algebraic expression 4ac by 2a. Okay, the equivalent C expression for this algebraic expression is, so here open bracket 4 asterisk a asterisk c close bracket by open bracket 2 asterisk a close bracket. So here the asterisk is the operator, whereas 4ac2, these are the operands. These are the operands, and asterisk is the asterisk and this division symbol. These are the operators. Operators, and these are the operands. Next example, if you observe the next example here, so this is the algebraic expression 2x square by b minus c. Okay, the equivalent C expression for this algebraic expression is bracket of bracket 2 asterisk x asterisk x close bracket by, there is a division symbol, b close bracket minus c minus c. See, this is the expression, C expression for this algebraic expression. So here 2x b c, these are the operands, and asterisk and division minus, these are the operators. These three are the operators and these are the operands. 2x b c, these are the operands. Okay, so these are the expressions, algebraic expressions, and these are the equivalent expressions for the for this algebraic expression. These are the equivalent, uh, we call them as the C expressions for this algebraic expressions. Okay. So next we discuss about operators. Okay, operators, C operators with examples. Okay, there are various types of operators are there in C programming. Okay, the first type is arithmetic operators. Arithmetic operators. The arithmetic operators are nothing but, okay, plus, minus, asterisk, division, and modulo. So these are the arithmetic operators. Plus is for addition, minus is for subtraction, asterisk is for multiplication, and this is for division. This symbol is for division, and this is the modulo operator. Modulo operator. Okay. So the division gives the quotient value, and the modulo gives the remainder value. The modulo gives the remainder value, and the division gives the quotient value. And we know that this is the multiplication, this is the subtraction, this is the addition. Okay, so these are called as arithmetic operators. And the second one is relational operators. Relational operators. The two types of relational operators are comparison, okay, and equality. The comparison operators are less than or equal, greater than or equal. All these are called as comparison. We compare the operands here. In comparison operator, by using this comparison operator, we compare the operands, two operands. And next one is the equality operators. Okay, equality operators. These are used to check the condition, equality condition, whether it is equal or whether it is not equal. So this is to check whether the operands are equal or not. This is used to check whether the operands are not equal or not. Okay, these are called as equality operators. And the third type of operators are logical operators. Logical operators. So here this is the logical and this is the logical or, and this is the logical not. Logical not. These are called as logical operators. And the next type is assignment operators. The two types of assignment operators are simple assignment and shorthand assignment. Okay, in simple assignment, so this is the equal symbol. So this is called as simple assignment operator. The equal symbol is called as simple assignment operator. And then this comes under shorthand assignment operator. See, plus equal. See, this performs addition operation, and then the result is assigned to the variable. Another example is there, asterisk equal. So this performs multiplication operation, and then the result is assigned to the variable. Another example is there, minus equal. This performs subtraction operation, and the result is assigned to the variable. Another example is there, division equal. So this performs the division operation, and the value is assigned to the variable. So here it is the modulo equal. Modulo equal. So this performs modulus operation, and the result is assigned to the variable. So all this comes under shorthand assignment operators. Shorthand assignment operators. And the next type is increment or decrement operators. Increment or decrement operators. Again, these are two types. Prefix increment. Okay, this is the prefix increment, and this is the prefix decrement. Okay, and next step is postfix. So this is the postfix increment, and this is the postfix decrement. Okay, and the difference between the postfix and prefix is nothing but, in postfix, first we assign the value and then we increase it. In the case of postfix increment. Similarly, in postfix decrement, first we assign the value and then we decrease it, and then we decrease it by 1. Okay, so this is the postfix decrement. Whereas in the case of prefix increment, we increase the value first and then we assign the value to the variable. We first increase the value and then we assign that value to the variable. Whereas in the case of in this prefix decrement, first we decrease the value and then the value is assigned to the variable. And then the value is assigned to the variable. So that is the difference between prefix and postfix. And the next type is conditional operators. Conditional operator. These are two types: single ternary and nested ternary. Okay, in single ternary, so this is the example: question mark, colon. So this is the symbol for ternary operator. And nested ternary operator nothing but open bracket, question mark, open bracket, question mark, colon, close bracket, colon, close bracket. So this is nothing but nested ternary. Here this is one ternary operator. The ternary operator is nested in another ternary operator. One ternary operator is okay mentioned in another ternary operator. So this is called nested ternary operator. And the next type is bitwise operators. Bitwise operators, okay, these operators are or the symbols are performed on bits. Okay, so here this bitwise AND, this is bitwise OR, this is left shift, this is the right shift, this is for negation or complement, we call it as a complement, and this is the XR. All these are the bitwise operators, and bitwise operators performs operations on bits. Okay, so these are the various types of operators that we use in C program. Okay, so let's we discuss about 5 types of arithmetic operators. Okay, so first, what is arithmetic operator? So arithmetic operators are used to perform arithmetic operations. By using this operator, we will perform the arithmetic operations. Okay, so the following are the various arithmetic operations, that is addition, subtraction, multiplication and division. These are called as basic arithmetic operators, or we call it as operations. And the following table shows various arithmetic operators and their meaning. So here it is. Okay, these are the arithmetic operators and these are the example and these are the meaning. So this operator plus operator, nothing but the meaning of this plus operator is addition. It is a addition. Okay, and the example is 2 plus 9. See, 2, 9 are nothing but operands and we are performing addition operation on these two operands, and the result nothing but the result is 2 plus 9, the result is 11. So this example, this is the minus, the symbol is minus symbol, this is called subtraction. The meaning for this minus symbol is subtraction, and example is 9 minus 2. So minus is the operator, 9, 2 are the operands. The result for this 9 minus 2 is 7. Okay, so this is the subtraction operator. And the next operator is asterisk. This is called as multiplication operation. This is called as multiplication operator. So here it is, we are performing multiplication on two operands 2 and 9. We are performing multiplication operation on two operands 2 and 9. The result is 18. So this is the multiplication operator. And the next operator is division symbol. Division, this is called as by. This is the division symbol or division operator. So here the division operator gives quotient value. See, whenever you perform 9 by 3, here we get the quotient value as 3. This will give quotient. Division gives quotient. Whereas in the case of modulo, it gives a remainder. Modulo division gives remainder. So this is the modulo symbol. That is percentile. Percentile symbol is called as modulo division. So 9 modulo 2. Okay, here the remainder is 1. Whenever we are performing 9 upon 2, okay, the remainder we get is 1. That remainder value is called as modulo result. And when we perform the division operation, here we get the quotient has 3. The quotient has 3. That is the reason division gives quotient, modulo gives remainder. Okay, all these are the various arithmetic operators. See, all the operators are called binary operators. Here All these operators are called as binary. The reason is all these operators are performed on two operands. Two, here it is 2 9, these are the two operands. Here it is 9 2, these are the two operands. Okay, 2 9, these are the two operands. 9 3, these are the two operands. 9 2, these are the two operands. That is the reason why we call it as a binary operators. All arithmetic operators are called as binary operators. And the modulo division gives the remainder of an integer division, as we explained before. Okay, the modulo, this gives the remainder. The modulo operator gives the remainder value. And arithmetic operators plus, minus, asterisk and division, or multiplication and division. Okay, this can be performed on, okay, double data types, integer data types. Okay, we can perform all these operations on integers and double variables or double values. Whereas in the case of modulo operator, this modulo operator is used to perform operations only on integer data types or integer operands. We will not perform float point operations on modulo by using this modulo operator. Okay, modulo operator is used to perform operations on integer operands only. Okay, whereas in the case of addition, subtraction, multiplication, division, we can perform both on integers and float values or double values. Okay, next we see a simple example or simple program which explains the modulo operator. Okay, so here, so A is the variable of type integer and we assign a 10 to the variable A. Okay, and here B is equal to 3. So B is the variable of type integer and we assign 3 to this variable, and C is the integer data type. So this is the variable declarations. We declare three variables A, B, C, and we assign 10 to A and we assign 3 to B. And here we are performing modulo operation between A and B. A mod B. Okay, and the result is assigned to C. The result is assigned to the variable C. And here we are trying to print the value, C value here. So printf percentile D within the double quotes comma C. So nothing but this will prints the C value. C holds, now the C value is nothing but C holds the remainder value. Whatever the operation we performed on 10 upon 3, okay, the remainder value is assigned to C, and that C value is printed here on the output screen. So whenever we perform 10 upon 3, the remainder is, we get the remainder as 1. That remainder value is nothing but we call as the modulo result. This A mod T, A modulus B result is the remainder value, and that value is assigned to C. Okay. So here let us execute this program by using Visual Code. Okay, let us execute this. I am creating file here, C file, and the name is, here I am giving the name as modulo dot C. So this is my C file. Okay, and here this is my program. So this is the documentation section. So I'm just writing here program to find modulo of two operands. Okay, so this is the documentation section. So documentation nothing but to increase the user readability. It is used to increase the user readability, and these are not part of the compilation. Compiler will not compile the documentation section. Okay, and next, so this is the preprocessor directory. I am including, okay, stdio.h. So this is the standard input output header file. Stdio nothing but standard input output header file. And next is the main function. The program execution starts from main, and this is the open braces and close braces. Main will have open braces and close braces. So within this main, I am going to declare variables int a is equal to 10, comma b is equal to 3, comma c. We are declaring three variables a, b, c, and we assign 10 to a and 3 to b. And then I am performing a modulo operation. C is equal to a mod b, a modulo operator b. Okay, and the result is stored in C. Here it performs a modulo b, and that result is assigned to C. And now we print the result here. Okay, the modulo result is percentile D. So this is C. Percentile D, in the place of percentile D, we have to print the result. Okay, so this is the program to find the modulo between two operands. The two operands are A and B. A is having 10 and B is having 3, and we are performing the modulo operation, and the result is assigned again to the C, and here we are printing the value, C value. The modulo result is percentile D. Percentile D nothing but it is the value which is in C. So let us run this program. So here this is the result. The modulo result is 1. Here it performs A mod B, and the result is stored in C. Okay, the result is stored in C, and here we are printing the value. The modulo result is 1. Okay, why? Because 10 upon 3, whenever we perform 10 upon 3, the remainder is 1. Here we get the remainder is 1, and that remainder value is the modulo result, and that value is assigned to C. Okay, so this is a simple program to find the modulo operation between two operands. Okay, so next, see, the modulo operator cannot be used with real operands. As we said before, the modulo operator, this is the called modulo operator. This is not used along with the real operands. Okay, we can only use this modulo operator on integer values only. Okay, so whereas in the case of division operator, that can be used on any operands. So if you observe here, the operation integer upon integer, this is division, integer, division, integer. Nothing but integer upon integer. Whenever you perform operation integer upon integer, the result is in integer form. The result is in integer form. So here example is 2 upon 5. 2 is an integer, 5 is also integer, and the result we get here is 0. The result is 0. Whenever you perform integer upon integer, the result is also a integer value. Here the integer value is 0. And next here it is a real upon integer. So we are performing a real upon integer. The result is, here the result is a real value. So observe here 5.0 is a real value and 2 is the integer value. Here we get the result is also a real value. Okay, let's see, whenever you perform integer upon real, so the result is also real. So here 5 is integer value and 2.0 is real value. So whenever we perform 5 by 2.0, we get the result as 2.5, which is a real value. Which is a 2.5 is a real value. So here another example is there, real upon real. So whenever we perform a real upon a real operation, the result is also in real value. The result is also in real value. So here 5.0 is real value and 2.0 is also a real value. So whenever you perform division between two real values, the result is also a real value. 2.5, it is also a real value. Okay, so these are the various types of division operations. Integer, this is integer upon integer, this is real upon integer, this is integer upon real, and here it is real upon real. Okay, let us see a simple program which performs arithmetic operations, that is a simple addition operator. Let us take one, let's see one example. Okay, so I am just creating a new C file, that is arithmetic dot C. Arithmetic dot C. Okay, so here this is the documentation section. I am declaring a documentation section here. Program on arithmetic operation. Okay, it is addition. Here we are performing addition operation. So this is documentation section. This is called documentation section, and C compiler will not execute this documentation section. This is only for user understandable purpose. Okay, and next, here it is the preprocessor directory. I am including hash include std io.h. So this is the preprocessor directory, and it is the main function or main method. The program execution starts from main, and here I am declaring a variable I, j, k of type integer. I, j, k are the variables of type integer, and also I am assigning 20 to I and 21 to j, and here I am performing addition operation I plus j. I am performing addition operation between the operands I, j, and the result is stored in k. And now I am printing the result here. Printf, the addition value, the addition result is percentile d. The addition result is percentile d, and it is the value is in variable k, ends with semicolon. Okay, ends with semicolon, and here it is the close bracket. Okay, so this is the program which performs addition operation between the two operands I and j. I holds 20 and j holds 21. The addition operation is performed between the 20 and 21, and the result is stored in k. And the result is stored in a variable k. And here we are printing the value here. The addition result is percentile d. Percentile d nothing but it is the value of k. The value which is in k. Okay. So let us run this program. So here this is the output. The addition result is 41. Yes, when we are performing 20 plus 21, okay, the result is 41 and that value is stored in K. We are performing I plus J and the result is stored in K. And in this case, we are printing the K value here. The addition result is percentile D. We are printing the output or we are printing the K value here. K holds the result of 20 plus 21. The result of 20 plus 21 is nothing but 41. Here it is the output. The addition result is 41. So this is the simple addition operation. A simple arithmetic operation, that is addition. We are performing addition operation. Okay. Okay. So this is for today class. Okay. Thank you to everyone.